Modern infrastructure, like the massive footprint of an AI data center, requires specific geotechnical data to support thousands of tons of structural load. Before the first concrete pour begins, engineers must understand exactly how the soil will respond to that weight. Today, we are going to take raw borehole data and transform it into a fully hatched geological cross-section using the GEO5 stratigraphy program. By the end of this workflow, you will have a complete, properly formatted drawing that is ready to be exported directly into CAD software or used as the basis for a comprehensive 3D model. To follow along, make sure you have GEO5 stratigraphy open and load a project file where your terrain shape and boreholes have already been entered into the system. Translating these isolated field tests into a unified cross-section allows us to visualize the subsurface as a continuous model, bridging the gaps between individual boreholes. When you open any GEO5 software program, your primary control center is the vertical toolbar located on the right side of the interface. The core operational rule for this software suite is simple. You work sequentially from top to bottom. Each time you click a button on this right toolbar, the central frame updates automatically to enter the specific data required for that step. If you reach a section that does not apply to your current project, you can simply skip that button and click the next one below it. Following this strict vertical flow ensures you provide all necessary geometric and material parameters before the program attempts to generate final calculations. Step 1 is to set up the geometry. Go to the right toolbar and click the Soil Profiles button. Because we already imported our borehole data, the program has automatically generated the initial vertical soil profiles for us. If your field data comes from other sources, like CPTs or SPTs, you will need to manually enter those specific profiles into the frame. Next, click down to the Cross Sections button. Here, you will select the first and last boreholes in your sequence to establish the physical width of the area we are mapping. With the boundaries established, toggle the program into Create Geological Section mode to begin mapping. We map boundaries by drawing lines between matching material interfaces, connecting fill to enclose the space between boreholes. Select the correct line type carefully. Mapping a structural fault or isolated lens requires different settings than a continuous boundary. Drawing these interfaces translates your scattered data points into a continuous, predictive map of the ground conditions. Now that we have enclosed geometric zones, we must assign material properties to them. Click inside any of the zones between your interface lines to open the profile editor. Inside the editor, assign a specific geotechnical type, or GT, to the layer. For example, assign your fill material to GT1 and your sandstone layer to GT2. If you have adjacent layers that share the exact same geotechnical type, you can use the Merge tool to combine them and clean up the section's visual complexity. Once zones are assigned, the critical next step is clicking the Generate button on the toolbar. The software instantly fills the empty geometrical spaces you outlined with industry-standard hatching patterns and colors based on your assigned GT parameters. Hitting the Generate button confirms your raw geometry is successfully married to your material data, producing a true geotechnical model. With the soil defined, use the exact same line drawing method to map out the exact groundwater levels across the site. To detail your schematic, navigate to the left toolbar and click the Annotations button. Here, you can place custom descriptions, text boxes, and structural objects directly onto the desktop. A useful best practice at this stage is to extend your soil profile slightly beyond the outer edges of your cross-section. This makes it easier to cleanly intersect additional cross-sections later in the project. Finally, switch over to the Drawing tab located at the bottom of the screen. This section allows you to configure your title blocks, tables, and final output parameters. Once your layout is finalized, you can print the drawing or use the Export menu to save the file in standard DXF or DWG formats. You should also note the Geo Clipboard feature in the top right corner. This tool lets you copy and paste structured data between construction stages or other GEO5 programs. Taking time to properly configure your exports ensures your geotechnical data is legible and immediately actionable for the rest of the construction team. As you can see in this completed, print-ready layout, your cross-section is now fully prepared to be integrated into broader BIM workflows. A major advantage of the GEO5 ecosystem is that this data travels seamlessly, meaning you never have to build this geometry twice. You can import this exact 2D cross-section directly into the GEO5 slope stability program, allowing you to run rigorous factor of safety calculations on the terrain immediately. Mastering these digital workflows ensures that field data remains consistent across the entire design cycle, from initial investigation to final stability verification. For more information, subscribe to our channel or visit www.finesoftware.eu.